Welcome back to this next video in which we are discussing the electrocardiogram or ECG. Okay, so in the previous video what I did was explained the electrocardiogram pattern that you actually get to you. And we saw that the way that you actually get an electrocardiogram is by sticking two electrodes on two portions of the body. So we put one on the right arm and we put one on the left leg. I'll just move this down a little bit. Here's our little person. We put one on the right arm and the left leg. And we then measured the electrical potential difference between the two. And in this case we went from the right arm to the left leg. And we followed this electrical potential difference over time, and each cardiac cycle, what's going to occur is it's going to oscillate like this, it's going to have a pattern like this. And we discussed that the reason that it has a pattern like this is because of the electrical activity that is occurring within the heart. In particular, it's because of these intracellular currents that are moving between the cardiomyocytes in the heart, these cardiac vectors that are occurring throughout the cardiac cycle. Okay? So really, when we look at an ECG pattern like this, although what it is actually measuring is the electrical potential difference between these two different portions of the body, what it's really representing, and the reason it's so useful to us, is that it's showing us how the wave of depolarization is spreading through the heart. It's giving us a lot of information about how, as I say, the wave of depolarization is spreading through the heart, how the electrical signal is propagating through the heart, and that's why it's so useful to clinicians. What we're now going to talk about is what's called the 12-lead ECG. So I'll come down a little bit now, and we're going to actually talk about the 12-lead ECG, which is the one that is actually used in the clinical setting. Now, 12-lead ECGs, you attach a lot more than two electrodes to the body, and this is why people get very confused about 12-lead ECGs, because what on earth are you doing? But in fact, what we're doing with a 12-lead ECG is we're actually just doing 12 separate ECGs. We get 12 different pictures that will all show a pattern very much so related to this, but slight variants of this. And we're just going to be measuring electrical potential difference between different points on the body. We chose, when we generated this one, to pick the right arm and the left leg, and that's a brilliant one to pick because it's beautifully in line with the directions that the cardiac vectors are actually going, so you get a beautiful ECG trace like this. However, we could pick different points to measure the electrical potential difference between over the body's surface, and what we will get is slight variants of this pattern, but which clinicians can actually use to understand certain things about the heart. So they can use the different 12 ECGs to determine different things. We're not going to go into that in this video. That's beyond the scope of what we're going to talk about here, i.e. what clinicians actually use the different 12 ECGs to actually interpret about the heart. We're just going to talk about where the 12 different combinations of electrodes are going to actually be, so where we're going to actually measure electrical potential difference between. And I'm hoping that from the interpretation that we did of this classical one, this beautiful one here, you will be able to now go forth, get a picture of each of the different 12 ECGs of the 12-lead ECG, and you'll be able to start actually interpreting why it looks the way it does, okay, in terms of cardiac vectors and in terms of thinking where intracellular current is actually going to be going and what that will do to the electrical potentials at the 2 points that you've got the electrodes. So I'm hoping that from the interpretation that we did of this classical one, which is actually going to be lead 2 in the 12-lead ECG, you will be able to go forth and interpret all the others. Okay, so what I'm going to do now is just tell you about which electrodes, where the electrodes are going to be for the 12 other ones. So let's start by talking about where we are going to put electrodes on the surface of the body in order to do a 12-lead ECG. So we're only going to put 10 electrodes on, and that's the first thing that usually confuses people. When they hear about a 12-lead ECG, they think, right, we need to put 12 electrodes on, but no, you actually only put 10 electrodes on. The 12 leads, the leads of an ECG, refer to the wires that connect the two electrodes, and therefore determine where you are taking the electrical potential difference between. So that's why we're going to get 12 different ECG traces, but we don't need 12 different electrodes to do that. We can use different electrodes more than once. Okay, so we're going to put 10 electrodes on in total, and 4 of them are going to be on the limbs. We're going to put 4 limb electrodes on. Okay, so I'll go back to drawing a stickman here. So here is my stickman, and obviously we're just going to put 1 on each limb. Okay, so we've already got 1 on the right arm, we've already got 1 on the left leg. We're now going to add 1 onto the right leg, which will talk about the fact that actually we're not actually going to use this one in any of the leads. That one's there for technical reasons, which I'm not going to pretend to understand, and therefore we're not going to go into. It's for earthing. I don't understand what that actually means, but it's there for technical reasons. Okay, and then there's going to be 1 also on the left arm as well. Right, so we're going to put an electrode on the right arm here, an electrode on the left arm. We're going to have an electrode on the left leg and an electrode on the right leg. Okay, and it doesn't really matter whether you put them right at the ends of the leg, like at the ankles, or at the wrists in the case of the upper limbs here, or if you put them at the shoulder joints or the thigh joints here. You can put them anywhere. It doesn't really matter because everything's electrically connected to everything else. So the changes that you'll get, they will, obviously where you put the electrodes will slightly change the amplitudes of the different waves of the ECG, but it won't actually change the pattern. Okay, so you can put your electrodes on the 4 limbs here. So those are the 4 limb electrodes, and I'll discuss what we're going to use those for in a moment. Then what we're going to also have is 6 chest electrodes. We're going to put electrodes on 6 different positions on the chest, and what I now want to do is describe to you where to put these 6 different chest electrodes. And the way I think that this will work best is if you actually try and feel the places where you would put them on yourself. So I advise you to pause the video as we're going through this and actually feel down where you would actually put them. You will remember it best if you actually have felt and worked out for yourself where you would put these electrodes on yourself. Okay, so the 6 chest electrodes then, we're going to call them V1 to V6. Okay, and by the way, let me just give you the names for these. You just abbreviate right arm as RA, left arm as LA, left leg as LL, and right leg as RL. Okay, so we're going to call the 6 chest electrodes now by these names, V1 all the way up to V6. So let's start with where V1 is. So V1 is going to be in the 4th intercostal space to the left of the sternum. Okay, so let me describe how to find this on yourself. So firstly, let's just have a reminder of the anatomy of the sternum. So remember, the 2 main portions of the sternum are the manubrial sternum, or the manubrium. Okay, and this is the portion under the suprasternal notch, so you should be able to find this. If you go to your suprasternal notch, then it's the bone, the hard bone underneath the suprasternal notch. So pause the video, find your suprasternal notch, which is apparent because it's in between the 2 tendons of the sternocleidomastoid muscle, and then underneath that you should find the manubrium here. Okay, then underneath the manubrium you have the body of the sternum, and then there's a final portion of the sternum right at the end called the xiphoid process, but these are the only 2 portions of the sternum we need to be concerned about here. So here's the body of the sternum, and the junction between the manubrial sternum and the body of the sternum is easy to find on yourself. Okay, there is a it extends forward. There is like a ridge between these 2 that extends anteriorly, and that's known as the sternal angle, and this is very easy to feel on yourself. So what I want you to now do is find your sternal angle, and we're going to do this to work out where the different ribs are joining the sternum. Okay, so you should be able to find your manubrium, and then you should be able to feel a ridge just underneath the manubrium, and that is the sternal angle where you have the junction between the manubrium and the body of the sternum. Now, go above the sternal angle so that you know you're still on the manubrium. And what we're going to now find is we're going to find where the second rib actually joins onto the manubrium. So only 2 ribs are going to actually join to the manubrium. So we'll have one rib here and another rib here. So the first rib joins the manubrium and the second rib joins the manubrium. You will have trouble finding the first rib, where the first rib is actually joining your manubrium. That's quite difficult to actually palpate, but you'll have no problem hopefully at all in finding where the second rib is actually joining the manubrium. So try and feel one of your ribs. I'm doing it on the left side as we speak. I advise you to pause the video if you are struggling to find it, but try and find the second rib, and it should be sort of joining this manubrium just above where the sternal angle actually is, and that's how you can find your second rib. Now, if you go down then into the space below the second rib, that's called the second intercostal space. Then you should be able to go down to another rib below that, which is the third rib. Then go down into the space below that, you'll find the third intercostal space. Then go down to the rib below that, that's the fourth rib. And then go down into the space below that, that's the fourth intercostal space. So I hope you have now been able to find on yourself your fourth intercostal space. And you want the fourth intercostal space, I'll just add this on here. So let's have, here's the fourth rib. Here's the third rib, so you want this space underneath the fourth rib here, and we want to find the fourth intercostal space just to the left of the sternum. Okay, so here is where we're going to put V1. So we put V1 then in the fourth intercostal space just to the left of the sternum. So we're going to attach an electrode in there. Okay, or rather not in there, on the surface of your body. Now, V2 is then very simple. All we're going to do is jump to the other side, so we're going to go to the fourth intercostal space on the other side here, and that's where we're going to put V2. Okay, so we're going to attach 2 of these chest electrodes then to these fourth intercostal spaces, which are these spaces underneath the fourth ribs, just to the left and to the right of the sternum. Okay, so next one along, V3 is complicated to describe where V3 is, so we'll skip that one out. It's easier once we've got V4. So we'll now go to where we're going to put V4. So V4, at the moment what you should have is you should have your fingers feeling the fourth intercostal space just to the left of your sternum. Okay, if you haven't got that, pause the video and find it. Then what we're going to do is we're going to go down into the fifth intercostal space. Now go down into the fifth intercostal space, which will obviously be below the fifth rib. So you'll go now down past another rib, the fifth rib here, okay, and you'll go into the space below that, which will be the fifth intercostal space. And we're going to put the fourth chest electrode in the fifth intercostal space at the mid-clavicular line. Now what is meant by the mid-clavicular line? So up here you'll have the clavicle, which has this sort of shape here, the collarbone. It sort of curves round like so. Now at this point where the clavicle starts to curve backwards, so initially it's very far forwards, and you'll be able to feel this. Go up and feel your collarbones. Okay, they're the very apparent bones at the top of your chest. Okay, you'll be able to feel them curving round backwards. Now at the point where they start to curve round, the line that you can drop down from that point, this is known as the mid-clavicular line. Okay, so this is called the mid-clavicular line, and it should run just medially to the nipples. So if you follow it down, it should run medially to the nipples. So what you then need to do is go back to the fifth intercostal space and find the portion of the fifth intercostal space that is along the mid-clavicular line. Now obviously this is not an exact science, you need to get it around there. So that's where we generally sort of put V4, so in the fifth intercostal space along the mid-clavicular line. So I'll just put this fifth intercostal space here. Okay, so we put V4 there, and now that we've got V2 and V4, I can describe where you will put V3. So V3 is just put in between V2 and V4. So once you've stuck V2 and V4 onto the chest, what you can then do is just put V3 so that it lies in between the two here. That's why we needed to first describe where V4 was before we could describe where V3 was going to go. Okay, so that's where we'll put the third chest electrode. Now it's the same case for the fifth chest electrode, the fifth one is going to be put in between the fourth and the sixth one. So we firstly need to talk about where we're going to put the sixth chest electrode, excuse me. Right, so we're going to put the sixth chest electrode again in the fifth intercostal space, so keep your fingers in the fifth intercostal space. Follow the fifth intercostal space round, okay, and we're on the left side now. Stay on the left side from now on, okay, so we've only got one on the right hand side, which is V1 over here. So follow the fifth intercostal space round to the mid-auxiliary line. Now let me just remind you what is meant by the mid-auxiliary line. So now what we're going to do is we're going to look at someone's body from the left hand side. So I'm going to have them, here is their chest, like so. Okay, so this is the front, this is the back, and let's say they've got their arm raised up like so, and I'm not going to bother trying to draw their head there, okay, but their face will be here. Okay, so here is the anterior wall of the chest, here's the posterior wall of the chest, and they've got their arm now stretched upwards. Okay, so of course the area, the armpit area, is known as the axillary region, and the mid-axillary line means the line that you can drop down from the axillary region along the lateral wall of the chest here. So this line here, this imaginary line, is what we call the mid-axillary line. So to put V6 in its correct place, you're going to put V6 in the fifth intercostal space. You need to follow the fifth intercostal space that we located earlier round to the mid-axillary line, and then you'll put V6 here, okay, in the fifth intercostal space along the mid-axillary line. Then finally, to position V5, what you'll do is you'll put V5 in between V4 and V6. So let's say V4 is over here on our picture. What you'll then do is you'll position V5 so that it is in between V4 and V6. Okay, so that's how you put all of the chest electrodes onto the chest wall. Now let me describe how we're actually going to set up the leads. So these are all the electrodes that we're going to use for our ECGs. Now what we're going to do is we're going to connect them and measure electrical potential differences between different points to get different ECG traces. Okay, so we're going to have 6 limb leads in our 12-lead ECG, and we're going to have 6 chest leads, or precordial leads as they're also called. Okay, so the limb leads are just going to involve the limb electrodes. Now, we're never actually going to use the right leg electrode to actually measure the electrical potential difference between 2 points and generate an ECG, and that's because actually the right leg and the left leg are pretty much equivalent. If you were to instead attach, for instance, going back to the example that we did between the right arm and the left leg, if you were to instead attach it to the right, from the right arm to the right leg, you wouldn't actually see any difference, and that's because really both of these leg electrodes, their electrical potential difference, their electrical potential at these points is pretty much identical to the electrical potential at the groin. So they pretty much both have the same electrical potential, and therefore there really is no point in using the right leg as instead of the left leg. So in fact, the right leg electrode is there for technical reasons. It's used for earthing processes, which must just be part of the electrical circuits for actually measuring electrical potential difference. Okay, it's there for technical reasons is what I understand. So I've explained to you that what we're doing is measuring the electrical potential difference between 2 points. What are the actual technicalities of measuring the electrical potential difference between 2 points? I don't understand that. Physicists will be able to explain it to you, but that's why we need the right leg electrode there. It's used for technical purposes for the actual measurement process. It's not used as one of these electrodes which we're going to use to measure the electrical potential difference between 2 points and generate an ECG. Okay, so we're not actually going to use the right leg, we're just going to use the left leg to generate ECG traces. So what I now want to show you then is which 6 combinations are we going to come up with for taking the electrical potential difference between 2 points. Okay, so these are called the 6 limb leads then, and a lead, as I said earlier, is a wire between the 2 electrodes that we're going to use to use to measure the electrical potential difference between the 2 electrodes, and therefore generate an ECG trace from that. Okay, right. So, what 6 combinations are we going to use? Well, these are best remembered using a triangle called Einthoven's triangle. Okay, and Einthoven's triangle draws basically on the chest wall the 6 limb electrodes. So this is going to be called Einthoven's triangle. So what you can imagine doing is you can have the right arm up here. Okay, so here's the right arm electrode, and you can imagine it being up at the junction at the shoulder joint here, the junction between the upper limb and the torso. And the same with the left arm up here. Again, you can imagine the electrode being up at the junction between the torso and the upper limb. And the left leg, I've told you that its electrical potential is effectively equivalent to the electrical potential at the groin region. So I'm going to draw it sort of at the groin region here. So you can imagine having someone's torso here. So we can have it like this kind of thing. Here's their torso, their legs would then be down here, and then their arms will be here. Okay, and now what we can do is we can draw a triangle. Oops, that's gone horribly wrong, but never mind. We can draw a triangle to represent the different leads. So we've already seen lead 2, okay, which is measuring the electrical potential difference from the right arm to the left leg here. So I draw an arrow from the right arm to the left leg, because of course we're taking the electrical potential difference from the right arm to the left leg. It's important to remember that you must have directions here, because you are taking electrical potential difference from one point to the next point. Okay, so here is lead 2. Lead 1, a new one that we've never seen before, is going to be the electrical potential difference from the right arm to the left arm. So this is going to be lead 1 of an ECG, and these are the real names used for the different ECG traces that you get in a 12-lead ECG. So you'll get a separate graph for lead 1 here, where you're following the electrical potential difference from the right arm to the left arm here. And then lead 3 is going to be this one here, from the left arm to the left leg here. So this is lead 3. So again, the arrow is pointing from the left arm to the left leg here. Right, so those are lead 1, lead 2, and lead 3. Okay, but there's actually going to be 6 different limb leads, so we need 3 more. The next 3 are a little bit more complicated because they're not just going to involve 2 electrodes, they're actually going to involve 3 electrodes. And you might ask, well, how on earth can you have an electrical potential difference between 3 electrodes? What does that even mean? Well, what we're going to do is we're going to average 2 of them. We're going to take the average electrical potential at 2 points and then take the difference of that average to the next one. Okay, so what we're actually going to do is I will draw a dot there, and we're going to have 3 separate electrodes, 3 separate leads rather, which are going to measure the electrical potential difference between the average of 2 of them and the other one. Okay, and the way we show this on Einthoven's triangle is like so. So let me explain. So let's start off with this one here. So what we're going to do for this arrow that's shown here is we're going to look at the electrical potential at the right arm and the left arm. We're going to average those 2 together, so we'll take the mean of the 2 of them. We're going to add both of them together and divide by 2 to take the average. And then we'll say that average, what then is the difference from that average to the final electrode, which is the left leg down here. Okay, and that's what I'm representing by this arrow here. So this arrow of Einthoven's triangle, this represents one of the leads, which is the average of these 2, and then the electrical potential difference from the average of those 2 to this one here. So that's what this point here is sort of representing. It's representing the average of these 2. And that lead is known as the AVF lead. Okay, the F is for feet. It's the lead that is going from the upper portions down to the feet. Okay, now we can do it in the other combinations that are possible. So let's go to this one here now. So what we can do here is we're going to average the electrical potential at the right arm and the left leg. We'll get a number, and then we're going to say what's the electrical potential difference from the average of these 2 to the left arm up here. And if we follow that electrical potential difference over time, the ECG that we get is known as the AVL ECG, the AVL lead. Okay, AVL clearly for left arm up here. Okay, then this final one, the final limb lead, is going to be the final combination that we can do. So we're going to average the electrical potential at the left arm and the left leg, and then what we're going to ask is, what is the electrical potential difference from the average of the left arm and the left leg to the right arm here? And that one is going to be called AVR, R for the right arm. Okay, so those are the 6 different leads that are going to be called the limb leads of the 12-lead ECG, and you will get 6 different traces, one for each of these. Now, we have already drawn the classical one, which is lead 2 from the right arm to the left leg. I hope that you could start to imagine what some of these other ones would look like. They'd be more complicated because you're looking at a linear angle, basically. Okay, so for instance, if we look at lead 3 here, now it's not in line with the direction perfectly that the cardiac vectors are going, but still think it through. Think of how the currents are moving and what effect that's going to have on the electrical potential of these 2 points, and you will be able to work out what the ECG pattern would look like. You'd at least be able to have a very good go at working out what the ECG pattern is going to look like. Okay, so for instance, if we were to think about AVR here, we're taking the average of the left arm and the left leg, and then taking the electrical potential difference from there to the right arm up here. That, if you look at this arrow, that's effectively the opposite way round to lead 2. Okay, we're going from the down portion up to this portion. So in fact, this ECG trace, AVR, is actually going to look like an upside down version of lead 2. So some of these other leads, their ECGs will look very different, and it's just because of the different places that you're taking the electrical potential difference between. But the overall pattern of having a P wave, then a QRS complex, and then a T wave, that remains the same in all of them. Okay, so they're all just slight variants of each other, and I hope that from what we've explained about how the ECG is actually generated, that you'll be able to go forth, look at these different ECG patterns, and be able to have a good shot at understanding why they look the way they do in terms of how the electrical signal is propagated through the heart. So those are the limb leads then. Now let's talk about the chest leads. Okay, and this is simpler. So, in the chest leads, we do not just take the electrical potential difference between 2 points again. Instead, what we do is we actually use 4 different electrodes to work out, to produce an electrical potential difference between 2 points. So what we do in the case of the chest leads is we average together the electrical potential at these 3 different limb electrodes here. So we average the electrical potential at the right arm, the left arm, and the left leg together. So we take the average of all of the limb electrodes, and as I say, we don't use the right leg as a separate limb electrode. That's there for technical reasons, for earthing. Well, that's my answer if anyone ever asks me what the right leg electrode is there for. It's there for technical reasons, earthing. Okay, for the technical reasons of actually measuring the electrical potential difference between 2 points. Okay, so what we're going to do is we're going to take the average of the electrical potential at the 3 limb electrodes that we actually use, okay, and we'll get an average value there, and then we're going to take the electrical potential difference from the average of these 3 to each of the chest electrodes. So we will have a chest lead for V1, we'll have a chest lead for V2, all the way up to a chest lead for V6. Okay, so we'll now have 6 more ECG traces on our 12-lead ECG, which will be called V1, V2, all the way up to V6. And what they are showing you is the electrical potential difference between the average of the 3 limb electrodes and your chest electrode, your respective chest electrode. So V1 will be the average of the 3 limb electrodes to the V1 chest electrode. V2 will be the average of the 3 limb electrodes to the V2 chest electrode, etc. That's what it is actually going to show you. Now, what does the average of these 3 electrical potentials from the 3 different limb electrodes actually represent? Well, it is taken to represent the electrical potential actually at the centre of the heart or thereabouts. Because if you average these three together, you can think about the fact that you're actually getting the sort of electrical potential right in the middle of them. Okay, so the way that it's interpreted, and I know this isn't an exact interpretation, of course, but the way it's interpreted is that the average of these three electrical potentials, the average of the electrical potential at the right arm, and left leg, gives you roughly the electrical potential at the centre of the heart. So with each of these chest leads then, you are looking at the electrical potential difference from the centre of the heart to the surface of the chest at each of these 6 different locations. Okay, so when you're trying to interpret the actual patterns that you get on those 6 different ECG traces there, that's what you should think of. You are looking at the electrical potential difference from the centre of the heart to the chest wall at each of these 6 different locations. And also, just going back to these limb electrodes, limb leads, where we've averaged things. Of course, the average of the right arm and the left arm, that would be roughly up here. So in the case of AVF, you're looking at the electrical potential difference from around here, right in the centre between the 2 limbs, down to the groin region here. Just like this line is showing, that's the direction in which this one's going. And for AVL, when you average the electrical potential at the right arm and the left leg, you're effectively getting the electrical potential here, and then you're looking at the electrical potential difference from here to here, so it's again along this line effectively, and the same for AVR. Okay, so this is where I'm then going to end this video. As I say, we're not going to look at all the 12 different ECG patterns for the 12 different leads of a 12-lead ECG. The aim of this video, where I hope you're at now, is that you understand where the electrodes would actually be placed on the body in order to perform a 12-lead ECG, and that you have the physiological understanding that you will at least be competent now to go forth and look at the traces of a 12-lead ECG and have a go at actually working out why they look the way they do. Have a good shot at interpreting why they look the way they do in terms of how the electrical signal is propagated through the heart. Thank you.